Okay, it is 11:15, so we are ready to jump into our third session of today, and that is enhancing interoperability in ORCiD integrations and faculty reporting systems. This is going to be presented by Emily J. Blumenthal and Dolsy Smith. However, Alex Boyd, Zachary Hawk, Jacob Hatcher, and John Vail all also contributed to this and are here and available and will be able to answer questions as well today. Emily is a data sciences librarian at George Washington University. She brings a background in developmental cognitive science and years of teaching experience in statistics and research methods to her work, where she focuses on research design, statistical analysis, data management, FAIR principles, and inclusive education in computation and programming. Emily received her PhD in developmental psychology with a focus on quantitative methods from the University of Washington. Dolce is a librarian and a a software developer at the George Washington University, where he develops and contributes to open source applications, advocates for and supports open access initiatives, and provides support for faculty and students whose research involves programming and/or data analysis. All right, I'm going to stop my share now, and feel free to begin yours whenever you are ready.
Great. Thanks, Jill. I thank you so much. My name is Emily. I appreciate that introduction. And as you mentioned, Dulce and I will be speaking on behalf of a much larger team, and many of whom are here today. So thank you. Next slide. We're going to be talking about our project to enhance interoperability in ORCiD integrations and faculty reporting systems. Managing scholarly identities and academic records is critical but complicated. Faculty publish across multiple platforms, they apply for grants and participate in professional activities, yet tracking and organizing this information is often fragmented and time-consuming. Without a centralized, well-integrated system, faculty profiles and our institutional reporting can be incomplete, inconsistent, or difficult to maintain, ultimately obscuring achievements by adding administrative burdens. Migrating to better systems can improve things going forward, but there's a risk of loss of historical data from legacy systems. Next slide. That's why our goal is to build more connected, efficient, and sustainable system that ensures faculty work is findable, accessible, interoperable, and reusable, according to FAIR principles. By implementing a system that automates data collection, integrates with existing platforms, and preserves legacy data, we can ensure faculty work is easily discoverable and linked across platforms. We can reduce manual data entry, saving time and minimizing errors. We can support open science expectations by making research outputs more accessible. Ultimately, this transition creates a stronger research infrastructure, one that empowers faculty, simplifies grant applications, and ensures that their work gets the visibility and the credit it deserves. Next slide. With these improvements, faculty and the institution will benefit in several key ways. First, they get full credit for all their work, including conference presentations, memberships, and other professional activities that may have been harder to track in the past. Second, they'll be able to reuse their data for grant applications, institutional reporting, and annual reports, saving time and effort. Finally, by making research more widely accessible, this system enhances faculty visibility by increasing the reach of their scholarly contributions. Next. Before this transition, GW's faculty reporting system had significant limitations. Faculty were required to manually enter their data, all of their scholarly activities, which was time-consuming and prone to errors. Standard identifiers like DOIs, ORCiD IDs, and other persistent links were inconsistently applied, making it difficult to track and verify contributions across platforms. While the system had been in use for several years, it was poorly integrated with external academic databases, leading to gaps in records and to additional administrative burdens. This lack of interoperability made it harder to maintain accurate faculty profiles and limited the visibility of their work. Our new system, Symplectic Elements, directly addresses these challenges by introducing automation, integration, and standardization. It now integrates with major academic databases like Dimensions, Scopus, and Web of Science to automatically pull in publications, uses standardized metadata for publications and activities, reducing duplication and improving discoverability, and connects with ORCiD, ensuring faculty members' research outputs are correctly attributed and synced across systems. And for those who don't know, ORCiD, the Open Researcher and Contributor ID, is a persistent digital identifier that uniquely distinguishes researchers throughout their careers. By linking ORCiD with our faculty reporting system, we improve accuracy, eliminate redundant data entry, and ensure that faculty receive proper credit for their work across multiple platforms. This shift means less manual work, more accurate data records, and a system that truly supports faculty and institutional scholarship. Next slide. Even with these improvements, data integrity remains a challenge, especially with legacy records. Many older faculty profiles lack persistent identifiers, making it difficult to automatically match and transfer information. Additionally, Symplectic Elements, our new system, while it does integrate with many databases, doesn't capture all scholarly activities. So contributions like non-academic publications, service activities, and awards still require manual data entry. This highlights the need for ongoing curation and faculty engagement to maintain complete and accurate profiles. While the new system is designed to save time and improve accuracy, faculty often need to manually update certain records to fully benefit from its capabilities. The key to success is balancing automation with usability, ensuring the system reduces administrative burden while making it easier for faculty to keep their profiles up to date. And now I'll hand this over to Dolsy to explain what we did, how we did this.
Thank you, Emily. Hello, everyone. Thank you for attending this presentation. My name is Dolsy, and I'm a software developer and a librarian at GW. And this part of the presentation is about one specific part of this implementation of elements where we were able to leverage some technical expertise in the library, specifically to kind of bridge the gap between the data in the legacy system and this system offered by Elements. Emily's, I think, described well the kinds of advantages that Elements confers over other kinds of systems for tracking faculty research, namely its integration with lots of external databases in order to pull in standardized metadata about faculty publications. But it doesn't necessarily address the problem of other kinds of scholarly activity that aren't captured in those external systems, nor the problem that many institutions face when migrating to a new system of wanting to preserve the value that's embodied in the data from the old system. So our approach to building this bridge sort of focused on four major areas of work. Before going into these, I just want to note that this is only what I'm describing is only really a part of a lot of work that's gone into this implementation. So, our colleagues in faculty affairs, some of whom are on this call and can jump in during the Q&A, did a lot of work to lay the groundwork for this implementation and for this migration. And a colleague of ours from the library was part of that implementation team from the beginning. So this presentation is really just highlighting sort of our specific technical contributions. But I think there's a larger, this has also represented a larger collaboration between the library and faculty affairs at our institution. So just to go through the areas of our approach to specifically preserving the legacy data. The element system has a sort of data mapping tool that you can use to map data from, map data from a legacy system for ingest, but you still have to modify the legacy data in order to adhere to the format that their import tool requires. So we used Python scripts. We wrote some Python scripts to do that, to apply the mapping to the data in the legacy system. And while we're at it, we did what we could to extract standard identifiers from the records in the legacy system. So Emily mentioned this, but the key thing about this legacy data is that it wasn't really very standardized. The legacy system had a lot of free text fields where faculty would, sort of enter information, enter metadata about their publications or scholarly activities in any number of formats. Sometimes just copying and pasting formatted citations from a CV, that sort of thing. Elements is much more sort of robust metadata schema. So, a citation is represented as data in multiple fields, the kind of way you'd see it in like a reference manager like Zotero or RefWorks. So in order to match publications in particular that Elements might also be finding in external sources that it's connected to, like Scopus or Web of Science, we wanted to pull out any standard identifiers that were present in the legacy system data so that we wouldn't end up with duplication. In other words, if Elements is pulling a record for a journal article from Scopus associated with a particular faculty member, and that publication is also in the legacy database, if we could provide a standard identifier for it, then Elements would automatically match those two records together as sort of different versions of the same object. Otherwise, it would look like this faculty member had more publications than they actually do, because they would have two separate records for the same publication. I hope that makes sense. So we were able to extract those identifiers in many cases, not all. Things like DOIs and ISBNs that are pretty, where the string, the information string is pretty consistently, follows a pretty consistent pattern. That was relatively straightforward to extract. For other stuff that might be useful as standard identifiers, it was a lot harder to pull that out of the free text fields. So we didn't have 100% matching. We also were able to standardize a few other elements like dates, which made the ingested data in Elements better conform to their metadata schema. But there was, we sort of had to accept the fact that there was a lot of data that couldn't be massaged into the right schema, and we ended up sort of sticking that data in a miscellaneous, as it were, like a miscellaneous field, so that the faculty would still have access to that and then could use it to improve the record for that work or that scholarly activity in Elements if they chose to. The next part of this, or I'll just go into a little more depth on one particular piece of this data ingest work, which was around co-authors for publications. So this was a particularly thorny problem, and it was kind of a surprise that we were able to develop a pretty workable solution to it. And that's the issue of co-authors, which in Elements are represented as you would expect in a database, right? With fields representing each author and their name, first name, last name, initials, etc., so that it's easy to report out on, publications that share the same co-authors, that sort of thing. In the legacy system, authors were entered just as, a single string in a free text field. And they were entered in many different patterns, as you might imagine. So depending on, the faculty member's discipline and or just their sort of level of attention to detail. There were lots of different ways that these co-authors could be represented. And we wrote a parsing script, again, using Python and a tool called Lark to do some sort of complicated pattern matching and extract the individual author names from these strings. It's, as I indicated on the slide, it didn't work. Certainly did not work in every case. Probably, I think we got it a little better than 50%, but you know, roughly half the cases we were able to extract well-formed individual author records from a co-author string. But the part that was exciting to me as someone who thinks a lot about sort of data cleanup is that we had a very low false positive rate. And that seemed like a success insofar as it would be much worse to sort of incorrectly represent co-authors in this kind of record than to just say we couldn't identify the co-authors and have the faculty member go back and put those in manually if they wanted to. And again, that is a metadata element that improves reporting and discovery in the element system by allowing internal as well as external audiences to identify patterns of collaboration among faculty, et cetera. The final piece of work that we did as part of this process was to identify and ingest ORCiDs for faculty users of the system where we could find a match. So Elements uses ORCiD profiles, as Emily mentioned, in order to basically sort of identify publications in external systems that should be associated with a particular faculty member. So if they have an ORCiD and they've claimed it in the element system, that makes Elements algorithms perform much better in terms of harvesting external data and linking it to that faculty member's profile. In order to sort of make things easier for faculty users as they were starting to use the new system, we automated this a little bit by where we were able to extract DOIs from metadata in the legacy system. We used the open access database OpenAlex to find author records associated with those DOIs that had ORCiDs. And then we were able to match some of those on the name of the faculty member. So where we had confidence that this was the same publication, then we could, with a reasonable expectation that we would make a correct match, we could, parse the list of authors associated with that publication that we get back from the OpenAlex database and look for a match on the faculty member's name. And so that allowed us to sort of pre-claim, if you will, 100 or so ORCiDs, thereby saving the faculty member that step. Because we were also concerned, a motivating concern here was also that faculty wouldn't necessarily, not all faculty who might have ORCiDs would understand the utility of that in this context. And so if they skip the step of claiming their ORCiD, then the matches they're getting for their publications are not as good as they might be. Oops, I went too far, but I think I'm turning it back over to Emily now just to kind of review some of the results of this work.
Yeah, if you wouldn't mind going back one more slide. There we go. So before we imported all the legacy data, you can see an Elements profile here for Dr. Romana Rafat, who is a very prolific and productive researcher. And there's not a lot there. There's a lot of journal articles and conference presentations and a book, which is fantastic. And if you go to the next slide, I just wanted to show, actually, when I was looking at mine, Emily Blumenthal is a pretty common name. And without Elements knowing my ORCiD at the outset, I had to scroll till page 10 before I was able to successfully claim one of my articles, actually. And that seems like a lot of work. Well, it's nice I didn't have to enter it manually. It's still more than I would have liked to do. So after the sort of end result of our collaboration here on the next slide, you can see how robust this profile is, not only with information about publications and more complete information, but also detailed information about professional activities and other scholarly activities that were brought in and standardized from legacy systems, reducing the manual effort and the data risks, the data quality risks that come along with it. Next slide. So in sum, Dolsy, I want to reiterate what Dolsy said, that this is a small part of a much larger project. Our achievements through this small part and also through collaborations with many other units across the university, we're reducing manual data entry, saving time and reducing risks of those data quality errors, improving data integrity, creating consistent and standardized metadata, and enhancing profiles, capturing missing works, activities, and legacy data. Faculty now have richer, more complete profiles with less effort, and these changes mean that faculty spend less time on administrative tasks and more time focusing on research, teaching, and professional growth. Next slide. So very quickly, I know we are short on time here, but a crucial next step is this ORCiD integration. By expanding our elements to ORCiD workflows, we're enabling grants, professional activities, and profile information to sync automatically in ways that they don't automatically link right now from elements to ORCiD. Right now, the current state of the integration is fairly restricted to publications. And this allows faculty to build robust ORCiD profiles that faculty can use for Science CV, a CV management system used by researchers applying for grants, and integrates with ORCiD. That makes it easier for them to populate grant applications with verified, up-to-date information, again, reducing duplication of effort and manual data entry, which we're clearly not fans of. And next slide, please. So by preserving and enhancing faculty records, this has institution-wide benefits, increasing visibility of research, simplifying workflows, reducing administrative burdens, and supporting grant applications, making it easier to showcase impact. By improving these faculty records, this project demonstrates how libraries can lead interoperability efforts by innovating with APIs to streamline data workflows, preserving and integrating legacy data to ensure completeness, and building research infrastructure that aligns with FAIR principles. Additionally, and perhaps most importantly, it highlights the importance of collaborative problem solving, not only within the libraries, but different units within the libraries, with faculty affairs, and with other systems and units that can bridge the gap between legacy systems and more current solutions, creating resilient, transparent infrastructures for research. So working together, we were able to strengthen institutional research support, simplify faculty workflows, and enhance the visibility of scholarly contributions. Thank you all for listening in to our talk. And again, just one more shout out to the many units and many people who have contributed to this project. And I'd like to hand this over for questions.
Okay, thank you for that. That was really cool. I really like those faculty pages. If anyone has any questions for our presenters, please just drop them in the Q&A. I am not seeing any right now, but I'll give everyone a minute to gather their thoughts. I really sounds like a big project, and it is really, really neat to see everything that you shared with us. So thank you. Looks like we have a question now. Is there any integration between these systems and Alma/Primo?
I can answer that. The short answer is no. I I I think that if you're an Alma Primo customer, you've probably heard Ex Libris make a pitch for their sort of competitor to the Element system that is supposedly integrates with Alma and Primo. I think Elements is it in my observation as a system, Elements sort of does one thing and does it very well. So the integration with Alma Primo, I think for us would we haven't really discussed it, but I think the immediate task is just to sort of get an accounting of faculty research that is complete and sort of represented in a way that could be used in other systems. So that's an interesting thought for the future, perhaps, but not something we've contemplated at the moment.
Okay, thank you. Our next question is, did you compare with Ex Libris Esploro? I know I'm not familiar with Esploro, but I'm guessing maybe that is the Ex Libris product you were alluding to.
Yeah, so there was, I think others might be able to speak to this better than I. I'll just note that there was a sort of, at the very outset of this work, even pre-pandemic, there was a team that conducted a pretty thorough review of the different systems in this space, research, faculty, sometimes called current research information systems. We've been calling it faculty reporting system. Explorer was not something that we, I think, at that time considered very seriously. I don't know the current state of it, but I remember at the time thinking it wasn't even really clear to me, like sort of what Explorer was trying to be, whether it was trying to be a current research information system or a open access repository, institutional repository, or some blend of both. Again, I think from my perspective, Elements is really really well architected for its particular use case, even if it doesn't have some of the integrations that some of the competitors might have.
Okay, thank you. We have another question. Is there system integration with an IR, which I'm guessing is referring to institutional repository, like Haiku?
Sorry to keep answering all
Go
the
for it,
questions, please.
Dolsy. Yeah.
As I understand it, Elements does offer some integrations with institutional repositories. We have not explored that yet, partly because I believe they sort of charge extra for that, as it were. They do have an API, so that if an institution has the resources, they can build their own integration using the Elements API. But I believe some institutions have worked with Elements to sort of adopt one that Elements has developed for them, and I don't think we've ruled that out because we do have an institutional repository, not Haiku, but it's a Hyrax based institutional repository. So sort of the slightly older version of what Haiku is. So we haven't ruled out that integration. It just would be further on down the road.
Okay, thank you. We have time for one last question. What is the percentage of faculty at GW, George Washington University, who have ORCiD?
I'll take that one if it's all right. The short answer is we're not really sure. And that's because we've run the ORCiD R script that grabs anyone who has an affiliation with GW, but we haven't matched that with our faculty list. We did in the past have a read-only integration with ORCiD, But getting faculty to like click that one button was more challenging than we expected. I think because they maybe hadn't seen the value add. And one of our hopes with this project is that we can not only increase the number of faculty who have an ORCiD, but perhaps more importantly, increase the faculty who have a complete ORCiD, because ORCiD has those manual data entry problems. So a lot of our faculty have an ORCiD. Many of our faculty have multiple ORCiDs. And that's something that we are trying to improve, is that value add for faculty, making their ORCiD not only present, but also complete, and helping them integrate it with multiple systems to reduce the effort it takes to complete their ORCiDs. And it'll also give us a better picture. I mean, that's the holy grail of all of this too, right? Is getting a sense for many of us of what our faculty are doing. And that will give us a better sense of that as well.
Thank you. That is our last question. And again, thank you to all of you for this presentation. It was really cool to see, and I know that's been echoed in the chat. So thanks again. And with that, we will move on to our next presentation. Our presentation now, session 4, is Bookworm, a GraphQL API for exploring bibliometric data, presented by Alex Boyd, who was actually one of the contributors of our last presentation. So that is pretty cool as well. Alex Boyd is a software developer with the George Washington University's Libraries and Academic Innovation team, where they assist students and faculty with incorporating software and coding in their research projects, teach introductory coding workshops, and support the library with repository and archival software. All right, Alex, thank you for being here. I'm going to stop my share now, and whenever you are ready, you can get going.